I will move on to the next case study now, ladies and gentlemen. The next case study is going to be presented by Mr. Sanjib Panda, General Manager, Power Plant Jindal Stainless. A few words about Mr. Panda, requesting you to put your video on and unmute yourself, please. Mr. Panda has 29 years O&M project selection and commissioning of thermal power plants. He has been associated with Jindal Stainless since 2019. He currently heads plant operations in 2 by 125 megawatt PF fired units and 14 megawatt AFBC and TG. Prior to Jindal Stainless, he has worked with OTPC Stake Energy Services Tripura, GVK Power Gondwal Sahib Punjab, Lanco Infratech Kundapalli, Torrent Power Sujin, and GVK Power Raja Mundri, PPN Tamil Nadu, GSCL Dahej, and JK Corp Ragara. Requesting Mr. Panda to please put your video on.
Yes, ma'am. I have completed the slide. You can go to the next.
Yes.
Yeah, fly ash utilization on a day-to-day basis, we are doing 100%. However, in the last year, we could achieve 96%. And stack monitoring also, we are compliant to the data. Safe injury days also, as mentioned, 382 man days. And we have a system of safety, this safety observation, which system which gives an opportunity to each and every employee in our organization to raise the defects pertaining to the safety, health and environment issues, and which gets mitigated by the team. You can go to the next, ma'am. And these are some of the statutory compliance. We have been complying to every statutory requirement, as you can see in the slide. One of our WHRV2 boilers is under shutdown is under progress because it is going through major overhauling. Next, ma'am. Yeah, as we have the theme for this year, power plant O&M modernization and renovation, I would like to say something about the need of best O&M practices and the modernization and renovation in every power plant. So, power plants follow a wide spectrum of operation and maintenance practices, as we know. And they are based either as per the OEM recommendations or as per the best industry practices. But despite implementation of the best practices, we always find there are critical gaps in our operational KPIs, which ultimately results in the shortfall in plant performance, including loss of efficiency, generation, and availability and reliability. Which means, again, there is significant scope for improving the overall unit's performance, and that can be done by strengthening the O&M practices, equipment condition monitoring, reliability-centered maintenance practices, technology upgradation, renovation, and modernization. Good O&M practices in thermal power plants is significant as it can help in improving efficiency, performance, and ensuring the good health of equipment and also increased reliability. There is also a urgent need for knowledge sharing, skills upgradation of O&M personnel, which will ultimately yield the desired benefits what we are looking for in the overall operation and maintenance of the plant. What we have seen with the aging of the plant, there is deterioration and degradation if we follow the good O&M practices, then we obviously slow down the aging process, and that is what should be the objective of every power plant. And improving the power plant's performance through timely intervention for renovation and modernization is also important, which helps in preventing equipments and units degradation, and ultimately helps in sustained higher levels of plant performance. Next, ma'am. To achieve those ends in O&M best practices, modernization and innovation, we will go one by one. First will be the O&M practices, which is generally followed in power plants and which are desirable for the health and reliability of the power plants. First is obviously process optimization through implementation of OEM recommended procedures and industry best practices. So this is the starting point actually. Unless we follow the OEM recommended procedures and adapt the industry best practices, we will not be able to control the parameters as it is desirable. And these O&M procedures should be well documented as approved SOPs and SMPs, and they should be readily available to all the operating and maintenance personnel for reference in case of doubt, and also to be able to be conversant about the procedures. Third is establish system to continuously monitor plant efficiency KPIs such as PLF, auxiliary energy consumption, specific coal consumption, coal GCV, heat rate, specific oil consumption, coal cost of generation and cost per unit of generation, etc. Specific raw water and DM water consumption. These by continuously monitoring and able to optimize, we will be able to operate the power plants at an optimum level. Maintain optimum spares and inventory for timely maintenance, eliminate forced outages and improve reliability. So this short also, as from the maintenance point of view, is very important. And finally, the maintenance methodologies should be focused on reliability centered maintenance, preventive maintenance, corrective and predictive maintenance, which will increase the life and efficiency of equipments. Next one. Now the objectives on implementation of good O&M practices. When we say the need of the hour is to implement the good O&M practices, it is also important to understand why it is required and what are its objectives. And here I have listed out a few. First is to carry out operation maintaining rated parameters as per design and load condition. So whenever we operate our equipments and units, we need to operate at the rated parameters based on the design conditions and the load conditions. Second is to minimize the parameters and the TPs, specific, whether it is specific coal consumption, specific oil consumption, auxiliary power, heat rate, cost of generation and plant maintenance cost, etc. Third is to carry out optimized startups and shutdowns. So when we are following the good O&M practices, obviously the focus will be on to keep the equipment and maintenance always prepared, so that whenever we carry out startups and shutdowns, we are able to do it with optimum in the optimum given time and not make delays. Next is to maximize reliability and availability of power generation units. So by following the good O&M practices, we are in fact ensuring the reliability of the units and station, and also increasing its availability. To bring units downtime to minimum and eliminate forced outages. This is obviously ensured whenever we are able to keep the stations or units reliable and available. It increases, it reduces the downtime and eliminates the forced outages. Next is to carry out maintenance jobs qualitatively as per laid down procedures within stipulated time. So maintenance jobs also are done as per the laid down procedures and within the time. Maintain O&M records, analyze data. Whenever we do activities and practice and follow good O&M practices, we make records of each and every activity and then analyze the data and find out what are the issues and why the issues, if at all they are recurring, the reasons behind it, and we are able to take timely necessary action plans. Next is to plan for overalls, statutory inspection and the effective execution. To have effective overall monitoring mechanism. Just to mention, even whenever we do the planning well, we execute the overhauling well, we need to also monitor the overhauling activities whenever it is being done, and also post overhauling we analyze the data as to what are the gains, what we have achieved with the overhauling. Then to ensure sustainable O&M and preserving the environment. And finally, to ensure industrial health and safety. Next, ma'am. Now we have listed out long-term sustenance and risk mitigation projects. What we have thought that there are two reasons to it. One is as our units have been commissioned in the year 2007 and 8, which means 15 to 16 years have elapsed, and obviously the equipments and systems are prone to aging and showing its effects. So the need of the hour is to think towards the longer term to ensure that it is sustainable, and also come out with projects which will mitigate these risks. And here we have listed many of them as to our understanding. The first is we have thought of mill retrofitting through dynamic classifier, which will in fact bring down the unburnt carbon from the pulverization of the coal. Then we have also thought of on going for the online procurement of online coal GCV analyzer, which will give us instantaneous value and timely need for timely correction of the planned GCV. What happens here is the without the online GCV analyzer, we do the planning for the coal feeding, and there is a time lapse of almost 24 to 36 hours by the time we come to know from the feeder sample that the coal what we have planned for feeding is deviating by 200 to 300 or maybe 150 to 200 kilocals, which again affects on the specific coal consumption as well as the generation. And third is the sustainability of stack emission. As we are aware, the limits is 50 for the as per the regulatory year, and because of the variance in the type of quality of coal, there is a real challenge in maintaining the limit below 50 milligram per nm cube. So there is a thinking of going for reducing this through upgradation of technology in the ESP. Then retrofitting of WHRV coils and tubes to increase its reliability, which presently we are doing in WHRV2. Upgradation of TSI systems, and in the same way, next we have Max DNA DCS upgradation. These two are again based on the need of going for the new technological upgradation and also to ward off the aging effect. Then energy conservation through VFD installation in ID fans, and this is basically an energy conservation measure. Then redundancy online power back to prevent oil starvation in TG lube oil system. Generator rotor spare availability. Right now we have 2 units which are always in operation, so we do not have a spare unit where in case of any need of replacement of spare, or maybe to refurbish the any of the spare, there is no, we are thinking of going for a generator rotor spare. Next. I'll quickly go through as we are running out of time. Side stream filtration system. This again is to bring down the TSS in the system and also keep the cooling water system and the condenser tube clean, fills clean, so that we get the temperature, the delta T across the condenser, as well as the vacuum as per the design. Then converting RO water to DM water. Right now we have a RO water of around 70 Nm³ per hour, and this we are circulating from the cooling tower. We are circulating back to the cooling tower. So this we are proposing to convert to DM water. Then LP turbine final stage blades also we want to keep as spares. HP turbine inner casing and rotor. Also we would like to keep as spares. Then aging critical 220 kV circuit breakers for retrofitting and replacement. Similarly 220 kV isolators, then 33 kV SF6 circuit breaker panels. New substation building for 33 kV substation, and new storage area development and rail cum road connectivity. So these are the few long-term sustenance and mitigation, risk mitigation projects we have here. Next. Now the need is for innovation, modernization of CPP. As I had said, 2007 and 8 we had commissioned both the units which are 16 and 15 years old respectively. So obviously it has undergone degradation. Unit wise for mitigation, we have gone for hiring of experts consisting of ex-NTPC professionals from O&M, then coal stacking and yard loss management, experts from IITIS and Dhanbad for coal testing and coal combustion characteristics. For water chemistry also we have hired water chemistry expert. And we have taken their recommendations and observations, and we have tried to implement to mitigate and recover from the degradation and prevented more degradation in the system. So, considering the life of the boilers, we have also given order to BHEL, our OEM, for residual life assessment of both units. For the first unit we have done in 2021 and the second we have done in 2022. Major modifications and renovations have also been carried out in each of the shutdowns 2021 and 22, and we can see those. I will quickly run through in the next slides. Yeah, this is for unit 1, which was undertaken in the year 2021. I will quickly run through because this, I think, whoever wants to go into details can go through separately because of
We will keep the presentations available on our website post the event,
Yes,
so they can go through it over there.
yes, ma'am. That's what. But I will just touch upon the activities
Sure,
what we have carried out. Condenser
sure.
water jet cleaning we have done. Air acid cleaning in condenser we have done. Helium leak detection and all this to recover the condenser vacuum, which was initially 0.893, and we have achieved gone up to 0.914, a gain of 0.021. Which has given us 30 to 35 kilocal per kilowatt hour of increase in heat rate. Next one. Then quality checks we have done in the boiler tubes, apart from this 100% radiography test. So this has given us an opportunity to identify which all tubes have thinned out, so that we have taken timely actions to correct that. Then RLA, as I said, in both boilers we have done to understand the residual life and what actions needs to be taken to refurbish the boilers. Then complete replacement. This is one major activity we have carried out. Complete replacement of economizer coils consisting of around 250 coils in both of the boilers we have done, and this was one of the major causes of our reliability issue, because of tube leakages and all that. We were facing reliabilities, which has been addressed significantly. Next one. Then aluminum blasting for removal of deposits from turbine blades. This is to recover the heat rate degradation in the turbine. Refining of interstage HP and IP turbine has also been done. High pressure heaters internal inspection and rectification as per the observation has been carried out. This is on the turbine side, all three of them. Next one. Then retrofit of cooling water pump discharge valves. This has been the conventional butterfly valves, type valves have been replaced with three-way offset valves, which has increased the system reliability in case of breakdown in one of the pumps. Now we are able to positively isolate and work on this affected pump. Then next is replacement of expansion bellow in discharge line of cooling water pumps with new ones. This has also improved the reliability of the plant. Complete replacement of fills in two cells of cooling towers. This has ensured that we have increased the supplication of water effectively. Heat transfer has improved, and efficiency thereby has improved. Next one. In the boiler side also, we have done the cold air velocity test, phase array ultrasonic test. This is the cold air velocity test has been done to predict the velocities of flue gas in the respective zones and to keep it uniform. And PAUT is one of the methods, non-destructive testing by using the pulse multiple beams, which is able to assess the tube welds, and the weakened welds are identified on time, and they are repaired so that the reliability of the unit is increased. Next one. Replacement of conventional hot air gate by latest technology, guillotine type gates. This is done on the boiler side. So 5 numbers of gates have been replaced, and this has been done now for both of the units. So this has helped us in reduction in hot air leakages and improve the efficiency of the boiler. Then CFD analysis in boiler. This is to again ensure uniform distribution of airflow. Then penthouse cleaning and roof air sealing has been carried out in the boilers, which are again one of the best practices that are being followed in the industry. Next. We have in the compressors, the pressure drop across the dryers has been reduced, thereby reducing the power consumption in the compressors. Then valve blowing operation optimization has been done, in which we have saved on the time of valve blowing as well as the steam consumption, and thereby saving on the coal. And finally, the specific coal consumption has been decreased. And reduction in power consumption in cooling tower fan by installation of VFD, that has also been carried out. Yes. CO2 or dry ice cleaning of generator stator and rotor has been done as a best practice to remove the dust and micro debris, which in a conventional way are very difficult to be removed. Gasket and O-ring replacement of generator transformer, unit auxiliary transformer and station auxiliary transformer has been done to arrest the leakages completely. Installation and commissioning of motorized operated hot air gates in all 5 numbers of coal mills has been done by replacing traditional pneumatic gates. So this is one calculation on the improvement what we have received in terms of heat rate after Unit 1 shutdown. We have achieved improvement in 148 kilocal per kilowatt hour, which has yielded around 10.65 crores of gains annually. Now, Unit 2 shutdown, which has been carried out in 2002, you will see that based on our experience from Unit 1, we have, as we have gained so much of benefits in each and every activity we have undertaken, we have more or less carried out the same activities in Unit 2 also. I think you can go down, go through them one by one and find similarity, but the data and the outcome will be different because both are 2 different units. Madam, we can scroll through. Yeah, you can scroll through because more or less are in line with Unit 1. This we are trying to showcase just to let everybody here in the audience understand that there is so much of as I've tried to start with saying that there is a significant scope in the improvement potential, and this is what we have actually experienced by implementing in both our units, going into details of our pain areas, trying to establish the actions needs to be taken. Obviously, we have hired the experts in O&M as well as in other areas to understand what actually goes through in each of the problems, and then zero down into each and every problem and chalked out the action plans. And in each of the shutdowns, we have made sure that we are implementing as per the requirement, and we have got the benefits which I am showcasing before you all. Yes, ma'am. Next. Similarly, for Unit 2, as I said, both are 2 different units. In that, we have seen there was improvement of 148 kilocal per kilowatt hour in heat rate, and here in Unit 2 we have gained 180 kilocalorie per kilowatt hour, which means that there was more potential in improvement in Unit 2 than Unit 1. And we can also interpret it this way that based on our experience in Unit 1, we could still better our implementation in Unit 2. Yes, ma'am, next. This is again what is the calculation for the Unit 2. So we can go next. Yes, ma'am. Other than the shutdown activities in which we have gone for the refurbishment or replacement, renovation and modernization of systems and equipments, and in the overall unit improvement. Other than that, during regular operation, also we have chalked out several plans by going through brainstorming within the team and coming out with what are the potential areas where improvement is possible and can be done. And this is what we have come out with actually. Reduction improvement plans. First is the specific coal consumption reduction improvement plans, in which we have listed out what we can do in the boiler, what we can do in the turbine side. As you can see, we have listed out in the boiler cycle by blending of coal as per the requirement. We can, these are the action plans on the right side. What has been done for blending of coal yard visit and day ahead planning for optimizing blending ratio, mines visit and planning for quality lifting, practicing balanced first in first out pattern for coal consumption, saving in energy by reducing idle run hour of conveyor during stacking and feeding, implementation of projects considered for retaining heat value and minimizing spontaneous combustion. Similarly, dry flue gas losses, in that O2, CO2 level monitoring and APH outlet with the help of portable gas analyzer. We are also doing monitoring with ORSET apparatus also, weekly basis for each of the boilers. Close monitoring of FC, volatile matter as and temperature percentage in coal for minor adjustments in process like PA header pressure, male outlet temperature, auxiliary air damper position, etc. SADC adjustment, air ingress point arresting. With regards to unburnt carbon and in bottom and fly ash, PA header pressure adjustment, thermography in the furnace first pass for flame temperature mapping and correction, mill fineness and temperature control, airflow optimization through PA flow and total secondary airflow are being done. And then for condenser vacuum, effective usage of city fan 6 riser holding up with the unit which is getting low vacuum, CW pump strainers inspection regularly to avoid condenser tubes choking. Next, ma'am.
Mr. Panda, you will have to conclude in the next 3 minutes because we're already running short on time.
I'll do that in 2 minutes.
Thank you.
Yeah, okay. Then we have taken some measures on the reduction of specific raw water consumption, RO plant operation time maximization at rated capacity, which effectively reduces our makeup water requirement. Sample cooler service water recycling to cooling tower basin project. Raw waters, grade seepage water recovery to city basin through suitable measures. Maximum utilization of utility wastewater for bottom de-icing. Next, ma'am. Similarly, for auxiliary power consumption reduction, we have focused on individual equipments, the equipments which are taking a higher power consumption, like boiler feed pump, cooling water pump, ID fan, FD fan, or PA fan, coal mills. And in each of these, we have chalked out several action plans in how to actually optimize the power consumption and ensure that overall auxiliary consumption is reduced. And we have achieved that in the law, as we have seen during implementation. Next, ma'am. Similarly, compressors, air handling plant, auxiliary equipments, cooling water and pump house, DM plant, lighting system, everywhere we have made some action plans, and we are continuously ensuring that we are able to keep the auxiliary power consumption as per our target, and we are able to achieve it. Next one. This is one of the combustion catalyst dosing also we have done, and in the boilers, in both the boilers, and we have apart from improvement in the heat rate, we have also achieved other important like lesser deposits on the tube surface, on the pressure parts, and the clinker lowering of the clinker formation, and other intangible benefits also we have achieved. Next. These are a few things in the coal yard we are doing to monitor and minimize the loss. Thermal imaging of coal heaps, practicing ozone sampling, mechanized water drainage, and mechanized bunker cleaning. Next one. And this is one of the projects which we have taken in the our MRSS main receiving substation. This is our customer of our power generation. They are in fact responsible to distribute the power to the main load centers within the steel complex. And there was a problem of power system availability and reliability due to frequent downtime, and this has been achieved. Next, ma'am. So several actions have been taken to mitigate this. Some improvement measures have been taken, like RTV silicon coating has been applied on the insulators of the 220 kV, and some modifications have been done, like L cut has been provided in the dropping jumper and GT big entry side. Some backup protection relays have been retrofitted, and several measures have been taken, as you can see, and which has given us benefits, cost benefits by reducing downtime, and availability has yielded around 2.47 crores over the year, and availability and reliability has been improved, and obviously 100% safety is being achieved due to this measure. Thank you. Next, ma'am. This, I think, I request the audience to just go through. These are several of the operational maintenance best practices what we actually follow in our plant, and I hope every plant will be following up doing this, and we have also in fact learned a few practices, and I hope some of the practices can be followed by other plants as well. So this you can go through. You can scroll down. Now we are, as a global steel producing company, we have certain goals, organization level, so ESG goals we have, and JSL is in a journey to achieve the ESG goals. So we are working on a project Samanvay to select the ESG indices as per the roadmap for the future. We are forecasting our GHG emissions and reduction targets in line with the science-based target initiative. We are aligned with the government of India's goals of achieving net zero by 2070 and GDP emissions intensity reduced by 45% by 2030. Next, ma'am. So these are some of the key materiality issues which has been identified to actually address to reach to the ESG goals. Next one. Now there are several ESG decarbonization initiatives which has been undertaken at the organization level as well as at our site level. One is going for the green hydrogen, which is a chemical process, electrolysis process. to separate the hydrogen from the oxygen in water. So this is one area where we are working on to ensure that we are on the decarbonization journey. Next one. Next is compliance of renewable power obligation. Presently 0.5% of renewable power from the total power consumed, we are obliged to, or we need to comply to import and use it for our power consumption. This we are now going through as a decarbonization initiative, and as a part of the ESG goals, we have already in the process of commissioning of 6.1 megawatt of floating solar power project on our water reservoir. Then 21 megawatt of rooftop solar project is in the process of implementation, and 300 megawatt wind solar hybrid renewable project is also under development with MS New Power. It is a wind solar hybrid renewable project which will generate 700 million units per year through a mix of solar and wind technologies, and is expected to be commissioned by May 24. And in phase 2, this is the phase 1, and in phase 2 we are planning for another 100 megawatt of renewable power project to achieve our goal for decarbonization and ESG. Next one. Then we are phasing out the fossil fuel vehicles and going for the electrical vehicles, and already 6 units we have introduced in our site, and more are being introduced. And also as per the mandate of Ministry of Power, Government of India, biomass co-firing also is being planned, maximum of up to 7% as per the mandate that is being planned and is being executed. Next one. Yeah, these are several, because of our persistent and continual pursuing of energy efficiency, energy conservation efforts, and we are always being recognized and awarded in various forums. And as you can see, this is a list of awards and accolades we have achieved in the last 2 years, in fact, which I have listed down. And we are committed to go a long way in this journey of excellence. Thank you all for giving us this opportunity to present our present operating, maintenance, modernization, renovation, and improvement initiatives that we have taken. Thank you once again.
Thank you, Mr. Panda, for that elaborate presentation. Actually, we are absolutely short on time for our last session, but I'll take a quick question for you that had come from one of our attendees, but request an immediate, a brief response to that. So, Pashupati Gorai, the question is from, as per your slideshow, it was shown that dry ash utilization is 96%. Please tell us how it is possible, and in case of free brick ash, is there any requirement of ash utilization certificate from the brick manufacturer?
Madam, the question whoever has asked, may I know his name and which company?
Pashupati Gorai. I don't have the company name. I can just see the name.
That's enough. So I would like to tell him that we are, in fact, we have taken efforts, in fact, to develop the whole ecosystem around here. We have presently around 350 to 360 brick manufacturers and around 5 cement and asbestos manufacturers who are associated with us, and who are continuously on a day-to-day basis lifting fly ash, and even to some extent we are doing well in almost by year end this wet ash also, bottom ash as you call it. So there is no legacy as far as fly ash and bottom ash is concerned, as we have built the ecosystem in a way that we are able to dispose the entire. In fact, we are generating, if I'm not wrong, we are generating around 1700 to 1800 tons of fly ash per day, and around say around 10% of that means around 170 to 200 tons of bottom ash per day. And we are utilizing on a day-to-day basis 100%, and on a yearly basis we have done it 96%, and this is the way we are doing it.
Sure. Thank you so much. And with that